Hi there. This is the second video for Chapter 6, Part 2 for this unit, and it is going to cover three main topics: percent composition, molecular formulas, and empirical formulas. The first one, percent composition, basically tells us the relative amount by mass of an element in a particular compound. Here's our equation: percent composition equals the total mass of an element divided by the total mass of the entire compound times 100. So this is an example question. You'll have very similar questions on your practice quiz on this topic. It says, what is the percent composition of CO2? Well, we know CO2 is one carbon atom and two oxygen atoms. But by mass, what is the breakdown? What is the percentage by mass? So this is where this equation comes into play. Total mass of element. So you're going to, for each element, for the carbon and for the oxygen, you're going to do this mathematical process. You're going to take the total mass of that element in the compound. So in this case, we have one carbon. So for carbon, I take the total mass of the element. Since there's just one carbon, when I look at my periodic table, I see carbon's number is 12.0107. It's the molar mass. So that's where this number came from. And since there's just one of them, I didn't do anything to that number. And I divide that by the mass of the entire compound. So if I'm just going to do kind of a rough estimate of the math here. If we take carbon, which is about 12, and we take oxygen, which is about 16, it's 15.9994, but it's about 16 times 2, and we add that up, we get roughly 44. So that's where that 44 number came from. I took one carbon, two oxygens, using the masses from the periodic table, one carbon, two oxygens, and I added all that up. And that gave me that 44 number. So that's where that comes from. I do that math times 100. That gives me a percentage of 27.3, or right around there. Sig figs, I'm not going to be real strict on sig figs for this unit, but there you go. Excuse me. Next up, I do the same process for oxygen. Again, total mass of the element. In this case, the element is oxygen. And since there's two oxygens, I took 15.9994 times 2. That gave me 31.9988. And again, divided by the mass of the entire molecule, CO2, all of it together, times 100, 72.7%. One thing you want to make sure is that they add up to 100, because this molecule is only made up of carbon and oxygen, so these two elements percentages should add up to 100%. So that's that process. Fairly self-explanatory. The next two processes are a bit more complicated. So molecular formula, it's the actual number of each kind of atom in a molecule. So all the formulas we've been talking about at the beginning of this chapter, Chapter 6, Part 1, have been molecular formulas. It's the formula of the actual molecule. So to calculate the molecular formula, you do this process. And here's an example question. And I actually didn't type out the answer for this one. So you want to follow along. So the first thing I do is I calculate the empirical formula mass. So that is the mass of the empirical formula. And I give you the empirical formula here. NO2 is the empirical formula. So I want to calculate the mass of that. And I'm just going to kind of rough estimate it again. Bring up my periodic table. Nitrogen is 14.0067, which is pretty much 14. Oxygen is 15.9994, which is pretty much 16. So when I do that math, nitrogen was 14, and oxygen was 16 times 2. Add that up. 16 times 2 is 32, plus another 14 is 46. So, I calculated that. Now I divide the molecular formula mass, what's given to me here, 92.0 grams. So 92 divided by the empirical formula mass, what it just calculated, the mass of the empirical formula. So put that on the bottom. Do that math, and I get 2. 92 divided by 46 is 2. So what that tells me is that is the multiplier. So that right here, kind of looks like a Z, but it's a 2, is the multiplier. So what I do is I take my original formula, my empirical formula, NO2, and there isn't a number after the N. It's not written, but we all know it's there. There's a 1 there. So what I do is I take the multiplier and multiply all those subscripts by that multiplier. So the 1 here, because there's 1 N, that's going to become 2. Again, I take the multiplier and I multiply the subscript, the little number here, by the multiplier. So 2 times 2 is 4. So my molecular formula here is N2O4. Now, if we had done this math and our multiplier was 3, then my answer would be N3O6. Does that make sense? If my multiplier was 4 here, it would be N4O8. So the multiplier just multiplies the little numbers of your empirical formula, which then gives you your molecular formula. So this would be our answer right here. Again, you'll get some practice on this on the practice quiz. So the next type of question is an empirical formula. How do we figure out the empirical formula? And again, a little more complicated than the previous questions, but the steps are all right there for you. First thing we do is assume 100 grams of the sample. And basically what that allows us to do is just change the percentages to grams. If you notice, here's the actual question. You'll have questions like this on the practice quiz. I give you the percentages of the two elements that make up this compound. This compound is made up of 74.9% carbon and 25.1% hydrogen. So what I did, first thing I did was I just basically replaced the percentage with grams. That's all you do. That's step 1. Assume 100 gram sample basically means change the percent sign to G for grams. The next step is to convert grams into moles. It's been a little while since we've done this. So, starting number 74.9 grams. Starting unit goes on the bottom. What we're looking for is moles, because that's what it says to do, is convert it into moles. So grams to moles conversion. And the 12.017 again comes from periodic table, carbon right here, 12.017. Multiply by the top number, divide by the bottom number, gives me 6.24. I do that exact same process for the other element, which is hydrogen. Again, percent sign becomes grams, so 25.1 grams, times blank line, grams being the starting unit, goes on the bottom, mole being the unit we're looking for, goes on top, mole is always 1, grams again, for hydrogen, red number on the periodic table, 1.00794. So I do that math. So basically I did 2 mole conversions here, grams to mole conversions. I get 2 answers. I choose the smaller one. 6.24 is smaller than 24.9, excuse me. So I choose the smaller one, and I divide both of those answers by the smaller number of moles. So the wording's kind of weird here. It says divide all the moles by the smallest number of moles. Basically, you get your mole answers here, and you find which one's the smaller number, and you divide all the numbers by that smaller number. So what I did here, 6.24 being the smaller number, well, 6.24 divided by 6.24, that's easy, that's 1. 24.9 divided by 6.24 is 3.99, which is roughly 4. So what that tells us is our subscripts are these whole numbers. So the subscript for carbon is 1. The subscript for hydrogen is 4. And that's our empirical formula, CH4. Now I get another example here. Similar process. If you notice, grams to moles. I change the percent sign to grams and grams to moles. I do that for both elements, the carbon and the hydrogen. I figure out which one's smaller. In this case, it's the 7.39. So I'm going to divide each of these answers by 7.39. I do that. Now this time, it doesn't give me whole numbers. So if you look back at the steps here, if you get whole numbers, you're done, which is the first example. But in the second example, when we're talking about now, if not whole numbers, multiply all numbers by the lowest common multiplier to get whole numbers. Basically, you got to figure out a number to multiply both of these by to make them into whole numbers. Well, 1.5, if I double that, becomes 3. That's a whole number. So I multiply both of those by 2, and then so the carbon, we get a subscript of 2. Hydrogen, we get a subscript of 3. So my empirical formula ends up being C2H3, not C1H1.5. You can't have that. You can't have a decimal number for a subscript. So if you get a decimal number at the beginning of step 3, just figure out a number, start with 2 and then go up to 3, go up to 4. That's going to make that number into a whole number. And that's it. If you have any questions, stop back and see me right after break. Otherwise, have a great break. Come back in 2013. Hockey team will come back with their first win. And yeah, look forward to seeing you in 2013. Have a great break.